In this video, I'm going to demonstrate how to simulate an archery competition on the TI Nspire using Python. So we will be using Python. So before I go actually into the code, what I will do is to run the program so you exactly know what is happening. It will be easier for me to explain each of the steps in the code once you have actually seen the program run. So now what you see on the screen is the actual code. So I have imported a few modules. So I've got the TI draw module, the random module, the time module, the TI plot module, the system module, and the maths module. So these are the modules that I have imported. So let's just run the program. And I've got a list of competitors there. So the first person is Bill from USA. He gets 5 shots. So you'll see 5 dots on the screen finally. Then the screen will change, goes to the next competitor, which is James from UK. And once again, James will have 5 shots. And then it will change to the next competitor, which is Roger from Canada. And some of the shots are outside. You can obviously control that because I've just used the probability module. Then that's Lee from China. And finally, I have Jeet from India. So I have actually got 5 competitors, but you can have any number of them. And once all the 5 shots are passed, you will see it says finished. So I need to click the escape button, and now it gives me each one's individual score. So if I just go up there, that's Bill's score, total of 5. James was total of 11. Roger was pretty bad, total of 2. Then Lee was 13 and Jeet from India was 7. So the winning scores are arranged in descending order, and then finally here is the winning order. So now let's go and look at the code. So the first shaded area are all the modules that I have imported. So the very first thing I do in the shell module is to clear the history. Now this aspect is coming from the TI system module. So the system module is there to clear the history. And also I'm getting the screen dimensions. And if you want, you can print the screen dimensions. All you need to do is print A. So A is getting the screen dimensions, and I'm actually using that information later on. B is the radius of each of the rings actually. So from one circle to the other, by 20 pixels, I'm changing the radius. I have predefined the colors as a tuple within a list. So you'll see 1, 2, 3, 4, 5 colors for the 5 rings. That's the list of competitors. I have 5, but you can add any number of them. Then finally, I've got an empty list which I've called new. And before the competition starts, I'm saying print that this is an archery competition, and we are printing the results. So the first shaded area represents the competitors, and once the competitor comes in, the dartboard is cleared and you get a new empty dartboard. So the clear is doing that, and then after each shot the score will go into the empty list that I have there. And then I also have a list called new where I'll actually be getting the running total. And then the next part, I've got for j in the range. Basically what that is doing, it is actually creating rings for the dart. When I say rings, rings of a radius of 20 mm. So that negative b, if you remember, I stored b as 20. That means it's reducing the radius for each of the rings by 20 units. It starts with 100 and goes to 0. So it will go 100, 80, 60, 40, 20. That's the way I've got it working. And then I've got set color to red. Then on the left hand corner of the screen, you saw the name of the competitor. So the draw text is the name of the competitor, and that's giving you the position in the X and the Y direction. And I is the name of the competitor, which comes from basically for I in the competition. So when I is 1, it would be the first competitor. When I is 2, it would be the second competitor, and so on. and then fill circle. So I'm creating 5 circles. Those are the rings, and I'm putting a color of white to draw the text. Now the draw text is the score for each of the rings. So the outermost ring is going to be 1, then 2, then 3, then 4, then 5. So that's actually putting all those numbers. So for M in the range 1 to 6 are the 5 shots that each of the archery competitors are getting, and their dots are being recorded in black color, and we are finding the distance. Now the exact center of the screen in the X direction is 159 and in the Y direction is 106. So I'm finding the distance using the values of R1 and R2, which are obtained using the random integer. Now R1 can take a value from 59 to 259 and R2 can take a value from 6 to 206. Now some of these shots can also go outside of the screen because these are in rectangular coordinate system, not the polar. If I was doing it in polar, I would be able to control all the shots within the screen. And actually in the next screen or towards the end of the program, I'll demonstrate how you could actually convert it into polar coordinate form as well. So I need to record the distance, and the distance is actually going to fetch the score. If the value of k is greater than 100, that's actually outside the ring, so the score would be 0. If the distance is between 80 and 100, that's the value of k, then the score would be 1. And if it is between 60 and 80, the score would be 2. And if it is less than 20, then the score would be 5. And these scores, which is SC, get appended to the empty list that I had scored. So that's basically the scoring system. And then finally, what I've got over here is a sleep for 2 seconds. So that's the time between each of the shots. And then I'm appending the scores to the list which I had called new, and then new one, which is outside the loop, would actually have the final score over there. And then this command is printing the individual score for each of the competitors. So I is the name of the competitor there as per the list. And then once this is done, I need to click escape. The screen will display finished. I need to click escape, and then I'll be back on the shell screen where it will actually print the winning scores, which will be sorted. It is going to print the winning order as per this, and this backslash with an N is each competitor would be recorded in a new line. So that's really what the code is. And after this, I'm actually going to demonstrate, if you want to go into the polar form, how to do that. So this screen, the code demonstrates how to convert Cartesian to polar. So I'm using the math import module, and I'm defining the function Cartesian to polar, where the input would be x and y, and I'm actually rounding it off to 2 decimal places. So that dot to f is the number of decimal places in the float, and I'm formatting that. So the first part is getting the value of r, square root of x square plus y square. That's going to give me the value of r. And then in the other one, I'm getting the angle phi, which is tan inverse of y over x. And then it should give me the value for rho and pi. Now that's from Cartesian to polar form. Now here I'm going from polar to Cartesian in the next one when the angle is in radians, and in the last one I'm going from polar to Cartesian when the angle is in degrees. So you can see over there I'm inputting that as pi over 6, which is 30 degrees, and over here I've done 30 degrees. So let's just run this code. So if I run it, you'll see these two are the same. And if I just go back there, the input for this was 88 and pi on 6, and then 88 and 30. So these two should be the same because that was in radians and this is in degrees, so it gives me the same values. So that's converting Cartesian to polar or polar to Cartesian.